So this one here, we can take a known point here, that's an exact value, sine of pi over 4, and we're going to take that coordinate, find the slope at that point, find the equation of this red tangent line, and then we're going to use that tangent line to approximate a point at x equals 1, which is not an exact value. But it's pretty close. Pi over 4 is, I think, somewhere around 0.7 something. And at 1, it's close enough to give us a reasonable approximation of sine 1. Okay, so what we want to do is we want to, first of all, find the coordinate, x and y coordinate. Okay, at x equals pi over 4, y equals sine of pi over 4 is 1 over root 2. Okay, that's our coordinate. We want to find the y prime value to calculate the slope. Okay, so y prime is equal to cos x, so the derivative at the point of tangent C is going to be cosine of pi over 4, which is equal to 1 over root 2. Okay, so I'm going to plug that into my equation. Okay, then I have that here. My equation is then going to be, my tangent line equation is y equals 1 over root 2, which is my slope, x minus x naught, which is pi over 4, plus the y coordinate at pi over 4. Okay, so there's the equation of my tangent line. This is the line that I'm going to use to approximate the y value at x equals 1. Okay, so sine 1 is approximately equal to this value here. Okay, so maybe I'll write it like this. Sine of 1 is approximately equal to y of 1, which is equal to 1 over root 2 times 1 minus pi over 4 plus 1 over root 2. Okay, and then we can simplify that. That's going to be about, I don't know what that's going to be. That's going to be about 2 over root 2 minus pi over 4 root 2, whatever that number is, works out to be. Okay. All right, so looking at this one here, we want to do the same thing. We want to find the tangent line at that point. Okay, so when x is equal to 0.05, we're going to plug in. So it's going to be 1 minus 0.05 squared. Okay, I should really get a calculator for that. Okay, 1 minus 0.05 squared. And it's 0.95 squared. It's going to be 0.9025. So it's going to be 3 over 0.9025. That's approximately equal to, that's approximately equal to 3.324. I'm just going to round that to 3.2. Okay, so that's the actual value at that point. What we're going to do is we're going to use a point that's close to that. So we're going to use x equals 0. Okay, so we're going to use a point x equals 0 and y equals, in this case, y will be equal to 3. We're going to find a tangent line at that point, and we're going to use that tangent line to estimate the value of 0.05. So we're going to look like this. So y prime is equal to, that's going to be negative 2, I'll just put the 3 out front, 3, negative 2, 1 minus x to the negative 3 times negative 1. Okay, and that simplifies to 6 over 1 minus x cubed. Okay, so there's my derivative. I want to find my slope. So y prime at 0, the slope is equal to 6. So there it is. I've got my slope. I've got my x and y coordinates. I'm going to write the equation of the tangent line. Okay, the tangent line equation is this, 6 x minus 0 plus 3. There's the equation of my tangent line. This tangent line then is going to approximate the coordinate at x equals 0.05. Okay, so when I plug in 0.05 into here, y is equal to 6. Okay, so f of 0.05 is approximately equal to y at the same x value. Okay, and then if I plug it in, I get 0.05 minus 0 plus 3. Essentially, this is my run. Okay, I multiply by the slope, I get my rise, and I get the difference from that, the starting point of 0.3. Oh, sorry, x equals 3. So my y coordinate works out to be 3.30. Okay, so comparing that to the actual point, it's actually not too bad. Okay, so that's a pretty good approximation. The graph, just so that you know what this looks like, this looks like it would be, looks like we got vertical asymptote here. It kind of looks like that. Okay, if I want, I'm using that point there. I'm using that tangent line to estimate a point, fairly close. Okay, that's going to be a point just right about, just at 0.05. So that's my function. Okay, actually maybe I'll just draw the function in different colors so that's clear. The actual function looks like something like this. And that blue tangent line is approximating a point near x equals 0. Okay, this part here says the curve is concave up. Using property, explain whether the linear approximation is greater or less than the actual value. Okay, to do this, well, you can see very clearly when you draw the graph, that blue line is below the red line. Okay, so the blue line is a lower estimate of the actual value. And we can just generalize this. If this is concave up, my tangent line looks like that. My tangent line is always below the red line. Okay, so the tangent line is always below. It's always below the curve. Okay, if I have concave up, or sorry, concave down, okay, so something is concave down, my tangent line, okay, there's my tangent line. So any approximation near that tangent point, yeah, I'll draw a little bit better straight line there. Any point below, okay, so that blue line is my approximation. So tangent line is always above. Okay, so tangent line is always above the curve. This is when it's concave down. Okay, this is here it's concave up.